Class. Welcome to EDM Lesson 7.1, Inequalities and Mystery Numbers. Our objective today is to write and interpret inequalities and to graph the solutions. This is something that isn't altogether new, and so hopefully we'll go through this lesson rather quickly. So for our math message, Harry and Susan are playing Number Squeeze, a game they played in earlier grades. Remember, this is where they guess a number, your mystery number. Harry chooses a mystery number x between 0 and 50. Susan is guessing his number. So Susan guesses 7, and Harry gives her the clue that x is greater than 7. So we're going to graph that down here. It says x is greater than 7. So it doesn't include the number 7. Remember these open and closed dots? Open dot means does not include the number, and a closed dot means to include the number. Hopefully you remember this from earlier lessons. So we don't want to include the number 7. We want it to be greater. So we're going to find the number 7. So here it is 10, 9, 8, 7. I'm going to put an open dot there, and I want numbers that are greater. So all the numbers up here, up to 50. That's a lot of choice. Susan guessed 45. And Harry gives her the clue that x is greater than 45. Okay, this eliminates a lot of numbers. So once again, I don't want to include 45, so I'm going to use an open dot. I'm going to find the number 45, 41, 42, 43, 44, 45. I'm going to put an open dot there. And I want numbers greater than 45. And so I know now, after the two clues, that all of the possible answers are the ones here between 45 and 50. And so it says, what number should Susan guess next? Well, there are a lot of strategies here. My strategy is always to pick a number in the middle. So between 45 and 50, 48's in the middle. You could pick any number between 45 and 50, though. You could pick 50. You could pick 44. No, you can't pick 44. That's less. But you could pick 46, and that would also work. All right. So now that you see what we're doing, we're going to be graphing our inequalities. Let's move on to our next problem. All right. So they're going to play a game of number squeeze. And for problems 2 to 5, we're going to do the following. We're going to represent each clue for number squeeze with an inequality. We're going to describe the solution set for the inequality. And then we're going to graph the solution set that makes both inequalities true and list 3 numbers. That could be the mystery number. All right, let's take a look at the first one. Before we do that, though, I want to talk about some vocab. An inequality, and I see a lot of errors on this in math boxes. So let's make sure we know what we're talking about. An inequality always contains a variable, okay, and an inequality sign. You remember all those inequality signs: greater than, less than, greater than or equal to, less than or equal to, not equal to. And we also have a variable. So D is greater than 7 would be an inequality, or G is less than or equal to 12. Here's the variable. Here's the inequality sign. We also need to remember solution sets. And the solution set's all the numbers that make an inequality true. So if D is greater than 7, then the solution set is D equals all numbers greater than 7, and we write it. Do you remember these weird bracket thingies? I hate writing them. Okay, and you would write any number greater than 7. Okay, and that's our solution set. So we're going to be writing solution sets. So let's take a look at the first clue. Theo represents his mystery number with the variable y. The sum of y and 3 is less than 4. Sum is our clue word. It means the answer to an addition problem. So we're going to be adding y plus 3. And it says less than, so I'm going to use that inequality sign. Oh, wrong one. That's the greater than sign. Make sure you're paying attention. Remember, the alligator, oh, and now I highlighted, the alligator always eats the bigger number. Okay. Here we go. Let's try this again. Y plus 3 is less than 4. On the other side, it's a lot easier because we only have one step. The number y is greater than -4. So y is greater than -4. Let's find the solution sets here. Well, the solution set for the one on the right is easier because I don't have to do any calculation. The solution set, remember those weird brackets, is any number greater than -4. Weird bracket. But over here, we have to do a little trial and error. What numbers work? Okay, well, we could try 1. 1 plus 3 is less than 4. But that doesn't work because 1 plus 3 is 4, and 4 is not less than 4. So I like to keep a little chart of numbers that work and numbers that don't work. And so the number 1 didn't work. Okay. If I try 2, 2 plus 3 is less than 4. Well, that doesn't work because 2 plus 3 is 5. So that doesn't work. So the number 2 doesn't work. Let's try something smaller. What if I did 0? 0 plus 3 is less than 4. Well, yeah, that works. 0 plus 3 is 3. 3 is less than 4, so 0 works. What about a number that comes between 1 and 0? I'm going to pick the number half. 1/2 plus 3 is less than 4. By the way, that one up there worked. 1/2 plus 3 is less than 4. Okay, this equals 3 1/2. That's less than 4. That works. So the number 1/2 works. So by looking at this, I can figure out, oh, I want all the numbers that are less than 1, because 1 doesn't work, but numbers less than it do. So the solution set here is any number less than 1. And there's our weird bracket. Okay, so let's graph these. Any number less than 1. So I've got to find my number 1. Here we go. Here's my number 1. I don't want to include it because it's got to be less than, so I use my open dot. And I've got the numbers that are less. My second solution set says any number greater than -4. So I don't want to include -4. Oh, where is -4? Let's label these. -1, -2, -3, -4. I don't want to include -4, but I want numbers that are greater. And so our solution set, guys, is all of our numbers between -4 and 1. And we just have to pick 3 that it could be. I see 3 sitting here. So we can do -3, -2, -1, 0, etc. Let's try the next problem. Margaret represents her mystery number with the variable p. And so we have 2 clues. 1/3 of p is less than or equal to 1 4/10. Here's our clue word, of. And remember, of means multiplication in math. So this is 1/3 times p. And it looks like this: 1/3 p is less than or equal to 1 4/10. Our other clue is a little simpler. It says the number p is greater than 4. So I'm just going to write p is greater than 4. And now let's find our solution sets. All right, well, for p is greater than 4, this is pretty easy. I'm going to do my bracket here, and it could be any number greater than 4, because that's going to make that true. But over here, I'm going to have to do some math. I'm going to think about this over here. 1/3 p, 1/3 of a number is less than or equal to 1 4/10. Well, I'm going to look at this equal part, and I'm going to treat this like an equation. So I'm going to use inverse operations, and I'm going to do the opposite. So instead of 1/3 of p, I want 1 whole p. So I'm going to multiply each side by 3, because the inverse of multiplying, okay, the inverse of multiplying by 1/3 would be dividing by 1/3. And dividing by 1/3 is the same as multiplying by 3, because of, remember, keep, change, reciprocal. We change, and this is the reciprocal. So we're going to multiply each side by 3. We'll get 1/3 p times 3 is p. Okay. And 1 4/10 times 3 is 4 2/10. And so this will make it equal. Okay. So we know if we have that little chart of numbers that work, numbers that don't work, okay, 4 2/10 could equal p. It works. Now let's see if numbers higher or lower work. And I'm going to pick numbers that are easy to multiply by 1/3 to try. So let's try the number 3. 1/3 times 3. And let's see if it's less than or equal to 1 and 4/10. Well, 1/3 times 3, 1/3 of 3 is 1. Well, 1 is less than 1 and 4/10. So the number 3 works. Okay. Let's try another one. Let's try 6. 1/3 times 6 less than or equal to 1 and 4/10. Well, 1/3 of 6, 1/3 times 6 equals 2. 2 is not less than 1 and 4/10. So this does not work. So the number 2 doesn't work. Excuse me, the number 6 doesn't work. Wrong one. The number 6 doesn't work. So 4 and 2/10 works. That makes them equal. 3 works, but 6 doesn't work. So for my solution set, I think that it is going to be any number less than or equal to 4 and 2/10. Now we're going to have to graph these. Uh-oh, I don't see any 4 and 2/10 on here. Here's 4 and here's 5, but I have some markings in between. There are 5 spaces, 1, 2, 3, 4, 5, so they're fifths. And we remember that 1/5 equals 2/10, which equals 2/10. They sound the same because they are the same. So let's label these. If this is 4, this is 4 and 2/10, 4 and 4/10, 4 and 6/10, and 4 and 8/10. And now we can graph. So the first one says any number less than or equal to 4 and 2/10. Well, that equal means we need a closed dot. So I'm going to put a closed dot at 4 and 2/10, and we're going to be going this way to the left because we want less than. Our second inequality says P is any number greater than 4. So I'm not including 4. I've got an open dot, but it's going to be going to the right. So our solution set are these numbers between 4 and up to 4 and 2/10. So let's pick some numbers from there. Well, I'll bet you know that 4 and 1/10 is in between. But we can also think about this instead of 4 and 2/10 as 4 and 20/100. That means we have a lot of choices. So I could do 4 and 19/100. I could do 4 and 5/100. I could do 4 and 1, 9, 9, 9, 9. Some of you love those repeating. As close as we can get without actually going to 4 and 2/10. Let's try the next problem. So I want you to try numbers 4, 5, and 6 on your own, and then come back to the video, pause the video, come back to the video, and check your work. All right, guys, let's go over these. So Theo represents his mystery number with a variable x. Here's our clue. The product of x and 3 is less than or equal to 27. Here's our clue word, product. That's the answer to a multiplication problem. So that means I'm going to do 3 times x, which is 3x, is less than or equal to 27. For our next clue, it says the number x is less than 8.5. So that's pretty simple. We just write x is less than 8.5. Let's find our solution sets. Once again, the one on the right seems to be easier. I just want, for x, if x is less than 8.5, I want any number less than 8.5. That's pretty simple. Over here, I'm going to have to try some numbers because we have a little bit of work to do. 3 times x is less than or equal to 27. So over here, let's try something. I just want to try your numbers. So if 3x is less than or equal to 27, let's see what makes it equal. Oh, this is a math fact. 3 times 9, okay, is less than or equal to 27 because it makes it equal. So my little chart, 9 works, okay? Let's try a smaller number. 3 times 8 is less than or equal to 27. 3 times 8 is 24. So the number 8 works, okay? How about a larger number? 3 times 10 is less than or equal to 27. 3 times 10 is 30. This does not work. So the number 10 doesn't work. So I think we can figure out our pattern here. If 9 works, it makes them equal. That's as high as it can be. So our solution set is going to be, sorry, my brackets are weird, any number less than or equal to 9. So let's graph these. Any number less than or equal to 9. Here's the number 9. It can be equal, so I want to close dot. And less than means we're going to be going to the left. Over here it says any number less than 8.5. Oh, I don't have 8.5, so I'm going to add that. It's just less than, so it's not equal to. So really, guys, this is all I need, okay? Because it says less than or equal to 9, but it can't. None of these numbers right here between 8.5 and 9 will work because it says, oh, it also has to be less than 8.5. So remember that the solution set here, okay, is really just this area. You don't actually want, even though we put them in, you don't actually want these two parts because the only numbers that make both true are the ones that I highlighted. So what are 3 numbers that X could be? I see 3 sitting right there. It could be 5, 6, 7, 8, -22, and beyond. Let's check your next problem. Margaret represents her mystery number with the variable B. When you subtract 7 from B, this tells you order, guys. The difference is greater than 3. So that means 7 is subtracted from B. I start with B. Minus 7 is greater than 3. On the other side, the number B is less than or equal to 10 and 4/10. B is less than or equal to 10 and 4/10. For our first inequality, we're going to have to try some numbers. So let's try a number. Okay. If we said B minus 7 has to be greater than 3, I'm going to try 10. 10 minus 7 is greater than 3. Well, 10 minus 7 is 3, but 3 is not greater than 3. So in my list, 3 or the number 10 goes on the not working list. Okay. Let's try a bigger number. Let's try 11 minus 7 is greater than 3. Well, 11 minus 7 is 4. 4 is greater than 3. So the number 11 works. How about a smaller number? 9 minus 7 is greater than 3. Well, 9 minus 7 is 2, so that doesn't work. So the number 9 doesn't work. So I think we have enough information here to figure out that we want numbers that are greater. Well, could we do 10.5? Let's try it. 10.5 minus 7 is greater than 3. Well, 10.5 minus 7 is 3.5. And 3.5 is greater than 3. So 10.5 works. So now we can say, oh, it's numbers that are greater than 10. So our solution set here is any number greater than 10. For our next inequality, B is less than or equal to 10 and 4/10. That's easy. Any number less than or equal to 10 and 4/10. And we're going to graph that. Any number greater than 10, we don't want to include 10, so it's open dot going to the right. Any number less than or equal to 10 and 4/10. Uh-oh, we have to do some labeling. Remember, these are fifths, which is 2/10. So here's 10 and 2/10. Here's 10 and 4/10. 10 and 6/10. 10 and 8/10. I want 10 and 4/10. It's less than or equal to, so it's a closed dot here going to the left. And so any of these numbers here that are between greater than 10 up to 10 and 4/10 are possible answers. So we could say 10 and 2/10. I bet you think, oh, well, 10 and 1/10 are there. 10 and 3/10 are there. But remember, it's also 40 hundredths. So you could do 10 and 39 hundredths, and so on. Let's take a look at this last one. In this one, they give you the graph and you're supposed to write inequalities. So we're doing this a little bit backwards. So we're going to write an inequality for each end. So let's take a look at this end. We have an open dot at this number, which is 1.5. So we're going to pick, remember, an inequality is a variable and an inequality sign. So I'm going to pick B. I'm going to see B has to be, well, I want numbers that are greater than it, but not equal to. So just greater than 1.5. On the other end, I'm going to take a look. Here is my, oh, this is 3.5. And it includes it because it's a closed dot. So B, and we need numbers that are less than it. So B has to be less than, but it could be equal to 3.5. So to write a different set of inequalities, what we would need to do is do the same thing to each side of our inequality. For example, I could multiply each side of this inequality by 2 and write an equivalent inequality. It sounds kind of contradictory, but it's possible. So B times 2 would be 2B is greater than 3. Because all of the numbers that make this inequality true also make our first inequality true. And I can do the same thing on the other side. It doesn't have to be multiplying by 2. It could be, I'm going to add 5 this time. Okay? And so remember, we can't combine like terms. We can only combine like terms. This is a variable and a constant. So it would be B plus 5 is less than or equal to 8.5. There are a lot of different possibilities here, but as long as you do the same thing to both sides of the inequality, you will come up with an equivalent inequality. All right, guys, glad you're paying attention. Keep working, and I will see you during the next lesson. Bye.